Hi, this is Austin. I'm here to talk about Sprint 4. I'm going to start by talking about some of the stuff that you commented on in Sprint 3. First of all, fixed it so that Scene Manager now deletes itself. That was on my to-do list, but it's fixed now. For the .h file, first of all, big four functions are now here, and pretty much everything is in private, and I'm using an attorney, which I'll get to in a moment. But those were the things you commented on last time. Same with Scene. Pretty much everything's in private, except for the things that I'm pretty sure should not be private. Attorney for that as well. Updatable, private attorney. The only thing that's not is protected are the scene registration submissions, because the game object, as far as I can tell, needs to be able to call those from the frigate function, for example. It calls its own submissions. Drawable, same deal. Attorney, everything. Alarmable, also the same. So here are all the attorneys that I ended up making. Were a texture manager attorney, just for the delete, which we talked about in class. Shader and model as well, same deal. Scene manager I used in specifically the main engine function for the initialize, update, draw, and delete on the scene manager. Scene attorney, this one I need to make more organized at some point, like to actually make it more efficient. But for the time being, it has all these as friends, and it has the various registration and deregistration functions. So at some point, it's on my to-do list. I will go out and put specifically so that inputable only is friends with these functions, and so on for the rest. I just haven't done that yet. Updatable attorney, same deal. Separate at some point, but for the time being, it's for registration, deregistration, update, and the references. Inputable attorney, game object attorney. This one I think each of these goes with one of these functions, so that one I'll probably separate out as well. Drawable attorney, same deal. Alarmable manager attorney shouldn't matter, since it's only it's just for a type def that I needed to use in multiple classes. And then the alarmable attorney, yeah, similar to the rest of them. So I will separate those out at one point. I just haven't yet. So the next thing up is the use of multiple alarms. You can see that here I'm using the registration data and an array of that, as well as the 3 alarm calls. So here is the actual assignment to everything in registration data, and at various points you can see that instead of just using state, I'm using regdata_id.state and passing in the alarm ID. So that's, and then here's the switch statement, which we know is bad, but it should be fine in this specific case. And I will quickly debug to show you. You can see down here, alarm 0, alarm 1 and 0, 0, 1 and 2 and 0. They're all on different timers, but they will intersect sometime. So there it is. Alright, so here is everything for the input. Keyboard Event Manager, this is the master class that uses everything. So there's my public, that, process events, register and deregister, I think should be public, and it shouldn't matter because the user should never have access to the Keyboard Event Manager. Yeah, here's a map, and then the type def for the map and the pair, and then an actual instance of the list. Pretty simple. It just goes through, if it can find the thing, it just registers there. If it doesn't find it, it adds it. Same deal with deregister, and then just a printf statement for couldn't find the requested key. And then the actual process events, it just loops through and tells each one to process its events. So each of those is one of these, a key manager. Similar deal, just a list, 2 lists actually for the key pressed and key released. So here's the data for that. And the way I did it was to take the key press, check if it's true. If it is and the last frame was false, then it registers as key pressed. If the last frame was true and the current one is false, that means it was released, so that does that call. And then I set the current frame to the last frame, and then use that for the next check next frame, pretty much. Register and deregister are just 2 quick switch statements to erase from the correct list. And then here's the inputable trait attribute. The way I'm doing it right now isn't perfect, but I wanted to get something that worked first, and at some point I want to go back and make this into a map similar to Alarmable. But for the time being, I have a set amount of keys you're allowed to register, and then a set amount of commands, which is just the amount of keys times 2, one for registration, one for deregistration. And so it's here's my struct, the reg and dereg, and then the max commands, reg data, the number of currently registered and deregistered commands. Essentially, as long as I'm able to add a command of a certain type, I will add them here. Pretty simple. Inputable just goes through and erases everything that creates it, and then the register and deregister. I'm not using states because every inputable needs to be able to have multiple commands, so as far as I can tell, there's no real reason to use states here. So they're commented out just in case I end up needing them at some point, but I don't think I'm going to. Here is my revised GameObject class along with its own attorney. So you can see the only things that are protected are entry and exit. Everything else is private, and then there are functions for scene entry, scene exit that are virtual, and they're empty here. Connect and deconnect from scene. So that should be, and then the commands. So here's the actual body of the function. The submit entry and submit exit are more or less the same as in as they are with the pretty much everything else. The way I did the submit exit thing was I have a check for if pending exit is false, which is set false at the beginning. It will say that it'll do its thing, and then I actually forgot to do this, but I'll do it right now, is it'll set pending exit to true, and then it'll only ever call once because all the other ones will be blocked by this test. Connect to scene and disconnect from scene are pretty much taken directly from the slide, so I don't really have much to say about them. Again, they're pretty simple functions. And the enter and exit commands, pretty simple stuff, but this is what they look like. So here's the bullet class that I implemented in order to test my GameObject lifecycle. It's pretty simple, very similar to the one in Centipede. There are all its stuff. Here is its creation, its initialization, update, draw, and then the entry and exit are the main important ones. And as you can see, I have a debug message for both that I'll show you when I start debugging. And then a factory, again, pretty simple to the Centipede one. It shouldn't really have any surprises. And I will debug this to show you shooting. So I'll back up a bit so you can actually see it despawn. Watch here and down here. So I shoot, entered scene, it's gone, and it exits scene. And again, and then a few more. Yeah, lots of enters, lots of exits. And that should be all I need to show here. So these are just some miscellaneous things that were part of the sprint as well. Camera manager, you can see it's not a singleton anymore. I didn't really have to change pretty much anything with the function itself, so that's all still the same. And then the time manager. So it has a frame time and a total time, and it can return those. Those are public, since you obviously need to get, well, I mean, they're private, but the actual calls here are public. And then there is a time attorney to take care of the delete that I think I showed, but if in case I didn't, here it is. It's incredibly simple. And then the actual calculation. So as you can see, calculates time each frame in the scene. That was the only way I could think of to make sure that the frame time is always accurate. And then last but not least, it is also deleted, as you can see here. And I think that should cover everything